Hi there, Inkerma, not sure how to pronounce their name, has kindly sent me their laser distance meter for a review. It's a DM-262 and bilateral, whatever that means. I'm not paid for the video, but since I'm allowed to keep the unit, I mark this video as promotion. From previous reviews, you know that this doesn't stop me from sharing all my findings with you. Opening certainly gives me the premium mobile phone kind of experience. A very nice and sleek unit in a candy bar format. The box also has a manual in 6 languages, a nice holster which contains the USB charging lead, and a lanyard. And here's the explanation of why this is a bilateral laser distance meter. It has 2 lasers, one on each end, like a double-bladed lightsaber, Darth Maul style. I'm not so sure if I like lasers going in both directions. It makes it tricky avoiding hitting somebody. Operation is reasonably straightforward after a bit of practice. The top button turns the unit on and a long press on the bottom button turns it off again. It does auto power off if you don't use it for a while. The default screen is the dual laser mode indicated by the 2 arrows on the readouts and also shown in the arrow on the top left. You do a measurement by pressing the top button. The first press turns the laser on to allow you to aim, and the second one does a measurement. It shows the distances measured by the front and rear lasers and the sum of both. As this rather crude sketch shows, I found in the dual laser mode both laser readouts are referenced to the bottom of the unit, so the front laser measurement includes the length of the unit while the rear one does not. This is why adding the 2 numbers gives the total distance between the 2 obstacles. A long press on the upper right button switches the rear laser off. The front laser still measures from the bottom of the unit. Another long press on the upper right button changes the reference to the front of the unit. Also note that the display has this scrolling effect, showing the last measurements, which can be quite useful. By the way, even when the number is no longer on the screen, you can still get it back because the unit actually remembers the last 100 measurements and you can cycle through them. You can set the unit into a maths mode where it adds measurements. This can be useful if you need to find, say, the total length of a fence based on a lot of individually small measurements of distances between fence posts. Of course, instead of adding, you can also ask it to subtract if that's needed. A long press on the lower right button turns the beeper off, but this is not remembered and it goes back to beep after power on. With short presses on the upper right key, I can change the display orientation to make it easier to read depending on how I'm holding the device. A long press on the upper right key uses a larger font for the same purpose. This is how that looks like when I'm doing a measurement. I'm quite happy doing my measurements in meters, like this one, but I know some of you prefer imperial units. Not to worry, the DM-262 has you covered. A long press on the lower left key switches to inch. Another press to feet. And then to inch in fractions. And back to meters. So far so good. But there's a bug in the system if you use dual laser mode, which had me totally confused for a while, not at least because it involves imperial units, which hurt my brain anyway. We start again in meters, nice and easy, and switch to inch as before. But this number is incorrect. 0.334 meters are 13.1496 inch, not 17.204. Same for feet. This is wrong. And the same for inch fractions. Even going back to meters now shows a wrong value. Remember, I did not do a new measurement. The correct distance is still 0.334 meters. The conversion error is totally reproducible, but it's not a real problem. Doing actual measurements in inch mode fixes it. 13.188 inch, which my calculator converts back to 0.335 meters, which at 1 millimeter is close enough. The same is true if you prefer in feet. Doing actual measurements results in the correct value from then onwards. And of course the same applies to the inch fractions. By the way, the DM-262 remembers the unit chosen last and it becomes the new default for power up. A short press on the upper right key brings up the menu. By default, it's length measurements, but you can move the box cursor around with the plus and minus keys and the top key selects. The next mode is continuous measurement mode, followed by standard area mode where it takes 2 measurements to calculate an area. Same for the usual volume mode with 3 measurements. The next 3 modes are cool. They are called Pythagorean modes because the DM-262 can measure angles and uses that in interesting ways. This is followed by data recording mode, which allows you to browse through the last 100 measurements, and finally the angle calibration tool. Leaving the menu using a short press on the bottom key. I will explore some of these menu items in more detail, but first a look under the hood. There are 4 self-tapping screws that hold the unit together, but that's not enough. There are additional clips that need a spudger, but thankfully unclipping is not too difficult or destructive. The unit is quite packed, which is not surprising given that it contains 2 laser distance measurement units, one here which you can see easily and the other one there under the cover. The 1000 mAh lithium battery sits in the middle. 2 busy PCBs, and on the right is the display. The main PCB contains the charging circuitry, the display and the keyboard driver, and connections to the battery, the beeper, the other PCB and one of the laser assemblies. The microcontroller is a Mind Motion MM32 SPIN06 based on a 32-bit ARM Cortex MQ with 16 KB of RAM and 16K flash, and a usual collection of analog and digital IOs and timers. The daughter PCB is dealing with just its laser assembly and is therefore a smaller version of the main one, but contains the same microcontroller. In total, there's quite some processing power in this unit. Somewhere must be a chip for angle measurement, probably one of those MEMS-based gyroscope chips you find in most smartphones, but I did not want to disassemble further because that may cause the laser assemblies to move and therefore ruin the accuracy. And speaking of accuracy, I wanted to test that and compare it with my many years old Bosch laser meter PLR25, but that is far more difficult than I imagined. It is simply not possible to aim 2 laser meters at a wall and expect millimeter, that is about 0.04 inch, less than 1/16 inch, in accuracy. Differently built laser meters inevitably measure between slightly different positions, and buildings are simply not built that uniformly. Hence, I came up with this setup. The distance between the 2 objects on my bench is as exactly 0.5 meters as I can measure it with the steel ruler you see. The 2 objects are aligned exactly at right angles to the ruler, and I confirmed that their walls are exactly perpendicular to the table surface. First up, the Bosch PLR25. It is said to include its own length, that is, reference to its rear, and so I position it to just touch the right wall. The Bosch has no backlight, so the display is tricky to see for the camera, but it's 0.5 meters exactly. For good measure, I repeat the test from the left wall. And that also results in 0.5 meters exactly. Now for the DM-262, starting in the dual laser mode. Since I can, I rotate the display to make it easier to read and position it arbitrarily somewhere between the 2 walls. 0.499 meters, 1 millimeter less than the Bosch. Reversing it and also rotating the display, of course. And now we have 0.498 meters, 1 millimeter less than before and 2 millimeters difference to the Bosch. Switching to single laser mode, measuring from the back, same as the Bosch, and positioning it touching the left wall. Still 0.498 meters. And from the other side, again 0.498 meters. Here are the results in a table. Both the PLR25 and the DM-262 have the same accuracy spec, plus minus 2 millimeters. So it's not a surprise that their readouts differ by that. In fact, double the difference would still be in spec. I guess it just so happens that the Bosch agrees with my setup. I checked my ruler with another one and they agree with each other in a fraction of a millimeter, so it's of course possible that I made a small error when aligning the two walls that favor the Bosch, so I would not read too much into the fact that the PLR25 was spot on. As far as I'm concerned, the accuracy of the DM-262 is fine. I won't cover the usual area and volume modes, there's nothing interesting here, but quickly cover some of the more unusual stuff, unusual at least for me that is. This is the first of the Pythagorean modes. In this mode, the DM-262 measures the slant distance and the angle and calculates the two missing sides of the triangle, giving you height and ground track distance. If you are wondering why you would need that, just imagine an obstacle like a wall or fence that prevents you from measuring distance or height directly, or that the thing you are trying to measure is just a vertical surface, with nothing sticking out horizontally to bounce off a laser beam in a standard height measurement. I tried that out in the hallway. First I used the standard way of measuring the height to the ceiling, then I switched to the first Pythagorean mode, apologies for the shaky mobile phone footage, trying to do the measurement in one hand and filming it with the other. The result is 2.401 meters, which is 18 millimeters higher. The result is better if you use two hands to keep the unit steady when measuring. A steady hand is even more essential for the next mode, which I tried but have no usable footage to show. Anyway, this mode combines two measurements of the Pythagorean mode you just saw and simply adds the height result. This mode would be useful if you and the thing you are trying to measure are on different ground levels. My drawing shows the unit in two laser mode, and in theory that would work if you mounted it on a tripod or something like that, which allows exact positioning of the two laser spots. It's essential that the back laser in both steps hits the same common spot on the ground, and the laser spot for the foot of the tower is exactly below the top one, otherwise you get a larger height than there really is. In my test I found doing it freehand in two laser mode can at best give you a rough height that varies by as much as half a meter or more on a 10-meter target when doing multiple tests. Putting the unit in single laser mode and measuring directly from the ground is much better because it ensures that the common point is the same, and it makes it more likely that your top and bottom target points are on the same vertical line. And the last Pythagorean mode, which is the same as the previous one, but now the two steps are subtracted from each other, and this allows you to measure, for example, the height of a window that is so far up that without a ladder you can't get there and measure it directly. This mode suffers from the same problem as I mentioned before, which is why I show the DM-262 already in single laser mode. The footage can't do more than show the principle. The height of the window doing a direct measurement is 0.967 meters. Obviously you can't measure the window frame exactly. While you can easily target the upper area of the window, you can't really hit the lower part easily, especially freehand, resulting in vastly different results. It is better to aim for the wall and target points on the same horizontal where the window starts and ends, but again that requires a two-handed operation, keeping the unit steady, which is needed for any degree of precision. Anyway, this is just a demonstration of the principle, so let's proceed and do the two-step measurement, which results in 1.000 meters, 33 centimeters difference, more than a foot. I think this shows that these modes are not really for casual use, but need preparation and very careful handling to get usable results. Sticking to the single laser mode helps a lot, and keeping the unit steady so the angle does not change, because an accurate angle is of course really important for all the Pythagorean modes. So obviously I tested the accuracy of the angle measurement. I assume that the sensor uses gravity, which makes it important to confirm that the table surface is exactly horizontal before proceeding. Using this triangle tool as a guide, this should be a 30-degree angle, and the reading bounces between 29.9 and 30.1. And this side is 60 degrees, but it reads a bit higher than that, around 61.4 degrees. I decided to do an angle calibration. There is this menu item, let's see what it does. Upon starting it, the display shows a picture of the device in a specific orientation, starting with lying on its back as it already is. Pressing the upper left key tells the unit that it's in the correct orientation, and a single beep means it's starting the calibration. After a few seconds, a longer beep says to move it to the next orientation. Now it's supposed to stand up with a stylized arrow pattern pointing down. Now I understand why they put this pattern on. Smart. Pressing the same button starts the calibration in that orientation, and after a while the long beep says it's done. Now it wants to be upright again, but with the display up. Okay, here we go. And done. Now it should be on its side with a stylized arrow on the left pointing right and the warning labels on the right. And I'm messing it up. I put it exactly the wrong way. I did not realize this while doing the cal, only when I reviewed the video footage later. Anyway, the unit does not complain and the cal proceeds. Next, it wants to be put on the other side with the screen on the right. And the cal proceeds further to the last step, where the unit is put on its face. Now I understand why there is a delay before the cal begins. It allows you to press the button and then turn the unit over. After the long beep, the display is dark. The unit has turned off. This is exactly what should happen according to the manual. Freshly calibrated, I repeated the angle test using my test triangle. Disappointingly, the 60-degree angle is still not quite right. In fact, it looks as if it's slightly worse now. A big surprise for the 30-degree angle. It now reads 78 degrees. At this stage, I reviewed the footage of my calibration and realized the error. I repeated the whole cal procedure, but I spare you viewing it. Let's just say this time I made very sure not to mess it up again. Repeating my angle test after the second calibration, and to my relief the 30 degrees are back, but not any more accurate as before I started the whole cal thing. And the same is true for the 60-degree test. So it looks as this is as good as the angle measurements are going to get. My thoughts on the Inkerma DM-262? It's a good laser distance meter and it offers all the usual measurements and then some. The dual laser isn't that much of a time saver. It's great for very quick and rough measurements, but for precision, where careful positioning and targeting is important, I always found myself switching to single laser mode. This is especially true for using the Pythagorean method successfully. Even with a single laser, this needs practice and steady hands. But I love that the unit offers these measurements. It's a lot of fun, and they expand the range of what can be measured with a laser distance meter dramatically. If there's one thing missing, it's a way to mount it on a tripod for more accurate measurements using these modes. Maybe a mobile phone holder will work. It's definitely something I will try out. If you like my videos, don't forget to subscribe. There are more projects, repairs and reviews coming up, and it would be great if you decided to become a Patreon. That would really help this channel. Thanks for watching.